This video will describe the simulation of demand values using the example of Harry's Tire Shop on page 477 of the textbook. The information given is a historical probability distribution for the number of tires demanded in a particular day. The demand can be from 0 up to 5 tires, and the probabilities range from 5% for 0 tires up to 30% for 3 tires. The first thing we need to do is select a number of simulation trials and then simulate the demand on these days, calculating the average of that as the average daily demand. To set up the table we need to do the simulation, we take the probabilities and calculate a range, a lower probability range and a cumulative probability. For the first value, the lower number in the range is 0. The cumulative probability is always the lower range value plus the probability for that particular demand. Once we come to the second demand value, the lower number in the range is the prior cumulative probability. Cumulative probability is the lower value of the range plus the probability of that value. This pattern repeats for the remainder of the values. We can also copy and paste these numbers in Excel to the other cells. One thing we should always see if we've done this correctly and if we have a valid probability distribution is that the last cumulative probability is equal to 1. Now we need to simulate the demand using this distribution for a number of possible days. We'll enter the formula for the first day, and then we'll be able to copy this formula to the remainder of the days. Instead of using a random number table from the book, we'll simply generate the random numbers that we need directly within Excel. The random number formula is RAND followed by an open and close parentheses. This formula generates a random number between 0 and 1. Now we use this random number to find a simulated value for demand. This can be done with the VLOOKUP formula in Excel. The value that we're looking up is the random number. The table array is the array that includes columns C, D, and E, the probability range, the cumulative probability, and the tires demanded. We want to use absolute values on the row and column in this range so that we can copy this formula to the remainder of the simulation trials. The value that we want to simulate from this range is the tires demanded. Tires demanded is contained in the third column of this range, so the column index number will be 3. We can only find an approximate match for our random number in the table. For instance, if our random number is 0.735, what we want the lookup formula to return is a tires demanded number of 4, because 0.735 is in the range 0.65 to 0.85. To do this, we need to select the approximate match. This completes the VLOOKUP formula. One thing we'll notice about Excel that we'll eventually need to fix is that each time we hit enter, it recalculates all the formulas in the spreadsheet, including the random number formula. So now we see a different random number. What we'll do is once we've completed the spreadsheet, we'll copy the random numbers and then just paste the values, and that will avoid these values changing anymore. In the spreadsheet right now, we'll notice the random numbers changed to 0.629. 0.629 is in between 0.35 and 0.65, so we see the simulated demand value is 3. We need to repeat this concept for all the simulation trials. In the book, it shows 10 simulation trials, but there's no reason we can't do many more simulation trials to get a more accurate representation of the average. We'll try 1,000. I need to list the numbers 1 through 1,000 in the day column. So what we'll do is enter 1, 2, and 3, highlight these, and then drag the lower corner, and that will allow us to drag these values down for the entire column. If we simply want to repeat these other formulas on all the rows that contain a value in the day column, we can use a good feature of Excel, and that is to just click the lower right corner, and it will automatically copy all of these formulas down to all the rows where it sees a value in column G. This can also be done for column I. Each of these is a simulated demand value for one day. Since we're done generating random numbers, I'm going to copy the values in column H, and then simply right-click on that column header and do Paste Values. Paste Values is the picture of the clipboard with the 1, 2, 3. None of the numbers have changed, but if you go into one of the cells for the random number, you'll notice the formula is gone, and now just the random number is still in the cell. As opposed to the book, I'm going to calculate the average simulated demand at the top of the sheet so we can easily see it. And we'll do this with the average function. So the average demand is 2.919 in our experiment. We could also calculate the number of tires sold, let's say assuming 3 tires are on hand at the beginning of each day. As the book mentions, holding inventory of tires might be expensive. So we may only hold 3 tires at the beginning of each day to be sure that we don't have to hold too many. What this means is that on any given day, we may or may not sell a number of tires equal to the simulated demand. For instance, on day 1, the simulated demand is 4. But if we only hold 3 tires in inventory, our sales would be limited to 3. On day 2, our simulated demand is 2. Since we hold 3 tires on hand at the beginning of each day, we would be able to completely fulfill those sales. The amount of inventory would have to be set ultimately when considering the holding cost and the cost of delaying customer orders. The sales then will be the minimum of 3, which is what the inventory we begin each day with, and 4, which is the demand. Of course, the demand will change when we copy this formula down. In problem 1319, we make a similar calculation for sales with simulated demand values, and then also use this to calculate the sales revenue, the cost, and the profit. We can also summarize the simulated demand values in a results table. We can do this with the frequency function in Excel. We would highlight all of these cells under frequency and then type the formula for the frequency array. The things that we're counting are all the values contained in column I, the simulated demands, the values that we're looking up or summarizing are the tires demanded over here in column B. What I did to enter the absolute references or dollar signs here was to hit the F4 function key right after highlighting the range. We enter this formula, and then because we want it copied to this array, we would do Control-Shift-Enter right after entering it in the array. It goes out to column I and counts the number of times it sees these tires demanded entered there. We know that the sum of these is 1,000. So the percentage of each possible value that we observe is simply the frequency divided by 1,000. The cumulative percentage is equal to the probability or percentage for the first value, and then for all those below, it's equal to the prior cumulative percentage plus the percentage for the current value. We should see this roughly replicate the cumulative probability from above. This simulation method can be implemented to solve problem 1319 by simulating demand, calculating sales, and then also adding the calculation of the profits.